Hello everyone, my name is Mayank Jain, and in this video we're gonna discuss time and space complexity of various root finding techniques. Here's the question. The time complexity of bisection, regular, false, secant and Newton-Raphson method are, and space complexity of bisection, regular, false, secant method and fixed point iteration and the Newton methods are where the processor is equals to 1. So we will see this. First let it for bisection method. Here neglecting this all values, we just first skip to the while our loop. Here the loop is loop through linearly, that is each time if the absolute of a minus 2 divided by 2 is greater than 0.1, therefore it is linear. Therefore since the loop is linearly looping through all the variables, so here the the time complexity of bisection method is to the order of n. Same as the here all the only vectors are used, no more arrays or 2D arrays are used. So here the space complexity is linear, hence it is order of n. Same is for the secant method, or we can go for regular false method. Here is the regular false method. The while loop here traverse through the whole loop until it is ERR is greater than 0.1 and there is no more loop under the nested loop, hence it is traversing through the variables linearly, and hence the time complexity to regular false method is of the order of n. Whereas here all the variables are used, only scalars are used, no more vectors or any arrays or 2D array matrix are used, hence the space complexity of regular false method is linear, hence it is of the order of n. Same as for the secant method, the while loop here loop through this variable such that ERR is greater than E, that is the error permissible in our program, and it is linear, so the order of the time complexity of the secant method is of the order of n, that is linear. Same as for the space complexity, the variables, only variables and scalars are used over here, no more vectors or 2D array matrices are used, so the space complexity of this secant method is of the order of n, that is linear. Now for Newton-Raphson method, the while loop traverses through the program or traverses through the variables until n is less than 100, that is we have taken the maximum iteration, that is 100, it could be anything. Since the loop is traversing linearly through all the variables, hence it is of the order of n. Therefore the time complexity of Newton-Raphson method is of order of n, and so for space complexity only scalars are used, hence the space complexity for Newton-Raphson method is of the order n. So we can say that for all the root finding techniques, the space complexity and time complexity is linear, hence it is the order of n. Thank you.